Welcome back everybody. In this series of lectures, we are discussing about the concepts of operating systems. And in this lecture, we will discuss about the scheduling criteria. What is the scheduling criteria? It is very simple. Like as we know, there will be a processor which is executing many processes at the same time. So to handle how the processes are going to execute or to maintain the order or in which order the processes will execute, so CPU will do scheduling for that. For before doing scheduling, CPU will consider something known as scheduling criteria. So many parameters are there in scheduling criteria like CPU utilization, throughput, turnaround time, waiting time, and response time. So CPU coming to CPU utilization, at the time of scheduling, the CPU has to schedule the processes such that the CPU utilization should be high always. So generally it will be ranges between 0 to 100 percentage. Okay, coming to throughput, this is the number of processes a CPU is executing in a given time unit. For example, consider in 1 second, in 1 second, okay, in 1 second, the CPU is executing 100 processes. So we can tell that the throughput here is 100, like that. So number of processes the CPU is executing in a given time, it is known as throughput. Coming to turnaround time, before going to turnaround time, waiting time, and response time, so we will take an example. Consider there is a process, for example, right? In the ready queue, we have a process. Okay, the process is P1, for example. Every process will have some arrival time, right? Means arrival time means this is the time during which it will be added to the ready queue, right? One more is the burst time. This is the time the process needs for execution. For example, it arrived into the ready queue at the 5th second and it requires a burst time of, for example, consider 10 seconds, right? So it is entered into the ready queue at the 50 second. It requires burst time of the 10 seconds, right? So for example, before that, consider here we have a graph like this. We have a graph like this, right? So here process before P1 starts. For example, consider CPU is busy before starting the execution of P1. The CPU is busy. For example, consider for 7 seconds it was busy, right? From the 0th second to 7th second, CPU was busy, right? So CPU will not execute the processes during this time. It may be doing some other task, right? So after the 7th second, consider CPU became idle. So P1 started the execution. At the 7th second, it will start the execution, right? And it requires 10 seconds of bus time. So it will 10 seconds of bus time it requires. At the 7th second, it started the execution. More 10 seconds it requires. So it finishes the execution at the 17th second, right? So this chart or this graph is called as Gantt chart. This type of graph is called as Gantt chart. So here P1 started the execution at the 7th second. It is finishing the execution at the 17th second, right? Now coming to the definitions of turnaround time, waiting time, and response time. Coming to turnaround time, I have written the definition here. It is the time taken to complete the execution, right? So or it is the internal between submission of a process to the ready queue and the completion of a process, right? See, when it is submitted, okay, it arrived in the ready queue at the 5th second, but CPU is not executing at the 5th second. CPU started the execution at the 7th second. So 7th second is the submission time, and when it is finished at the 17th second, so turnaround time will be 17, that is execution finishing time, and the submission time, that is 7. So turnaround time here will be 17 minus 7, it is 10 seconds is the turnaround time. So again, turnaround time means it is the time which is it is the internal between submission of a process to the CPU and the completion of execution. This is called as turnaround time. Coming to waiting time, this is the time during which process will wait in the ready queue before execution, or it is not executing during that time. In our example, for example, see, it arrived at the 5th second, but it is starting the execution at the 7th second. So it is not starting the execution at the 5th second only. Okay, it is waiting till the 7th second and then it is starting the execution. So here waiting time will be, okay, it started the execution at the 7th second, right? Its arrival time, it arrived into the ready queue is at the 5th second. So its waiting time is 2 seconds, right? Why? Because it arrived at the 5th second. It is not executing at the 5th second. It is waiting for 2 seconds. Then it is starting at the 7th second for execution. This is called as waiting time. And coming to response time, this is same like waiting time. This is the interval between submission of a process in ready queue. Submission of a process in ready queue and when it is receiving the first response, right? So as we know, we have submitted at the 5th second and we are receiving the response at the 7th second, right? Response time will be in negatives, we will not call, we will not consider. Generally it will be -2, but in positive numbers we will take. The response time is 2 seconds, right? In preemptive scheduling, what happens? This is non-preemptive scheduling. Why? Because it is not stopping in the middle. When it is started the execution at the 7th second, so it is finishing the execution at the 17th second, right? So coming to in preemptive scheduling, it can stop the execution in the middle before completing, right? So more detailedly regarding this, the preemption and non-preemption types of execution, we will discuss in the next classes, next sections, right? So the better scheduling criteria are always, okay, so we have to maximize the CPU utilization, right? We have to maximize CPU utilization, right? Max CPU utilization, right? This is one. And another one is we have to maximize the throughput. And another one, the turnaround should also maximize. Sorry, turnaround time has to be minimized, right? Minimum turnaround time. And we should have minimum waiting time also, right? And we should have minimum response time also, right? Right? This is about the scheduling criteria. I hope that these concepts are very clear to you. So again we are going to discuss the brief we will see here. Okay, here before scheduling the processes, the CPU will consider the scheduling criteria. In the scheduling criteria we will see generally 5 things: CPU utilization, throughput, turnaround time, waiting time and response time, right? So here CPU utilization means the number of processes executing in a given time. For example, here in our example, in 17 seconds, 0 to 17 seconds, CPU is executing only one process. So its throughput is 1, right? CPU utilization, it ranges between 0 to 100%, right? And coming to throughput, number of processes it is executing in a given time. And turnaround time, this is the time from the starting of execution to ending of execution. Waiting time, this is the time during which the process waits in the ready queue. Response time, This is the response. This is the time during which it will get the first response. So generally this we will consider in preemptive type of scheduling, right? So more detailedly regarding scheduling algorithms and how to calculate this turnaround time, throughput time and waiting time, we will discuss in the next lectures. So for that, kindly stay tuned. Thank you all.